Hello, my name is Hugo and I'm a machine learning engineer at AB InBev. Today I would like to talk about a machine learning project that I have done, which is basically a fictional scenario where a fintech company has developed an application that promises to streamline the loan approval process, where instead of you, the bank client, having to go to a bank, filling a form, waiting for it to go through a tedious human analysis process and receiving an answer a couple of days, maybe weeks later, you can simply put all the informations with the help of your cell phone and receive the answer right away whether your loan will be approved or not, your loan request will be approved or not. So the focus of this project is going to be on the operationalization. How can we convert a model that is work minimally well to a microservice and deploy this and monitor this? So let's go. Basically, I'm not going to dive into details of this notebook, but this is the notebook that contains the R&D. I'm going to share all the code on my GitHub so you can take a look, send me feedback, etc., and we can discuss about it if you want. Basically, I use an Xgboost classifier to train a binary classifier, and these are the evaluation metrics. We got an accuracy score of 82%, but there is lots of room for improvement because we can see the recall for the scenario where the loans are approved is really low, right? 0 means the loan was refused, and 1 means the loan was approved. And although the precision is reasonable, the recall is really low. But let's move on with this version of the project. After we have a satisfactory version of our model, the first thing we have to do is to save our model artifacts. The things that are going to be necessary here are the model itself. We're going to save it into a binary version called a BST archive. Xgboost library already provides a save model method that you can use, very easy. And we're going to use the job lib to save the remaining things, which are the encoder for the categorical variables, the encoder for the target column, and the columns that were used in the training data set. This is important because we want to make sure that the data that is coming to perform predictions, it is in the right order, it has the same amount of columns, so like defensive programming. And after we exported this, we now have to create a script where we basically going to set up our web server. So one of the easiest ways to do this is using Flask. Basically, Flask allows you to set up your endpoints. I'm not going to go deep into the why things are written the way they are here, but let's just take a brief look. Basically, you create the application and you specify your different endpoints. This is going to be like the base endpoint. If you hit it, you're going to receive this message: welcome to the loan forecaster API. After you send a GET request, and the focus here is rather on this eligibility endpoint, which is going to receive post requests. And what's going to happen after we receive this post request is we are going to receive the data. For this, we need to import the request from Flask, receive the data. We are going to use the JSON loads to deserialize the data. Then we're going to navigate the JSON structure to get the data field. And then we're going to use the evolve function to basically convert the text into an actual Python string. Basically, this will make more sense when we actually create the predictions in the endpoint text, it's going to become more visible why this code has been done. So after we retrieved the data as a Python list or list of lists in case of more than one prediction, we're going to reshape it and put it in the model that in the format that the model expects, which is 16 columns and however many columns you send to perform the predictions. And then you need to instantiate the classifier to load the model. So here comes one of the first things that one of the model artifacts that we saved. We perform the predictions and we print it for logging purposes. If everything goes right, we return the 200 status code, a message, predicted successfully, and the prediction, loan approved or loan denied. If something goes wrong, we print the exception for logging purposes. We return the status code of 500 and return the message something went wrong. And the entry point of the script is when we actually run the app, and we run at localhost in port 8080 or the port that is specified in the as an environment variable. Okay, so let's test this and see if this works. So let me open a terminal. I already had some terminals open here. Let me close this. Clear. Okay, I am in the same folder where these files are. And first, let's run python app.py. So it is running on port 8080. If I go to this other terminal and I say curl localhost port 8080, so I'm using the base endpoint. If I hit enter, we get welcome to the Loan Forecaster API. If I want to use the other endpoint, it is possible as well, but I'm not going to do this now because the next step in the project and the operational industrialization of our model is to put all of this content into a container so we can turn it into a microservice. So let me stop the server, clear the screen, the terminal, and now let's go to the Docker file. Basically, in this Docker file, we start from a Python-based image. We set the working directory. We copy all the module artifacts necessary from the local machine, from our host, to the container image. We copy the requirements file, which is going to be used to install all application dependencies necessary. Then we copy the script itself. We then install the requirements. We create an environment variable called port, which is going to store the value of the port that should be exposed, which is 8080, the port that's going to be exposed in the container. And that's it. So let's build the container. Docker build T for tag. I'm going to call it Loan Forecaster, and the Docker file is in this folder. So it was pretty fast because I had already tested before recording the video, and everything is already cached. Okay, so now if I try to run this container and say docker run, I'm going to bind port 8080 in the container to port 8080 in the host, and I call it Loan Forecaster. I want to run the Loan Forecaster image. We should see that our application our server is running, but now as a containerized service. Now let's test our eligibility endpoint to see if our code work as expected. For this, I have set up this endpoint test notebook. So let me restart the kernel. Okay. I'm going to sample data from the training set so we can see, kind of simulate a stream of data. As such, I'm going to repeat the same pre-processing steps that I did in the R&D stage. If you want to take a look, uh, take a look at this loan legibility notebook. And okay, so it's time to test the endpoint. I'm going to use the requests library, requests Python library, and basically what I do here is I sample an index from the data set, I serialize it, right? Put into the format. Here you can see that is a dictionary that has a key, data, and the value is the record. That's why in this app.py that I said things would make sense, I did this process. Here I deserialize the data and I get what is in the I get the value of the key data. And basically I send a post request, get if the status is 200, I print the response. And here you can see that some loans are denied, some loans are approved, and we are getting some response. Okay, wonderful. Let me interrupt the execution. And now the next step is how do we leverage cloud services? How do we scale this? And for this, I'm going to use a Google Cloud Platform service called Cloud Run, which is the equivalent of ECS, Amazon Container Service, Elastic Container Service, and Azure also has equivalent services, but I'm going to use GCP's version. And basically, what we need to do is to create a service account that is going to have the necessary permissions for us to authenticate, because this API is not going to be public, right? We want our API to be secure. So let's go to Cloud Run. So here I'm in the dev environment of my company. I have already created the service here, but let's actually go to artifact registry. So artifact registry is a container registry service, among other things. And what basically you need to do here in this step, I'm not going to do it again, but you need to create a repository. And after you create this repository, you'll need to push your Docker image to this repository. So in order for you to do this, you basically need to authenticate your local machine. So I'm not going to be able to display this here for security reasons, but basically after you authenticate your machine, you can use the gcloud command utility so that it outputs a security token that you're going to use to authenticate your API calls. So if I run this, The result is going to be a dictionary which have this bearer token here, and this token is what is necessary for the API uh, for the service that was deployed using Cloud Run to recognize my identity and allow me to query the API. What is going to change now is basically that the endpoint is going to be different. And actually, let's get back. We created the repository here, and now if I go to Cloud Run again, I could go to create service, and here is where I'm going to specify the container image that was pushed to artifact registry. So you can see after it loads, you can see that we have some the region and the project and the repository. And I'm using, this is my repository name, Loan Forecaster, and this is the image that I'm using, right? So I could select it here and name the service and specify the minimum number of instance, the maximum number of instance, and here is where I set the authentication, and in my case I have selected to use Cloud IAM to manage the authentication process, and that's the step that you're going to need to do. But if your Docker image is working properly, this is fairly straightforward. And after you hit create service, your service was created. Then it's time to test and see if things are actually working. So let's get back to Visual Studio, and I'm going to hit enter, and we can see that we are sending the post requests, we are getting the answers here, right? And if we do this, let's try to put it side by side. Oh no, bugs. We can see, like, in almost real time, the amount of instances that are being used, the rate. I think this is refreshed every 5 seconds. Here we have the counting of requests. Yeah, it's going to be refreshed. We can see how long does it take for our instances to return the predictions. And it's sending 1 request per second, so it's not very, there are not a lot of predictions in a short amount of time. But well, that's basically it. So this way you can basically convert a machine learning model that you developed into a service that can be integrated into an application. And I hope you enjoyed it. Send me feedback. This is basically my first video talking about MLOps, and I appreciate your attention. Thank you for watching it, and bye.